Question 2 is our standard sort of Poisson binomial, all the rest question. And I did just have to check that I hadn't accidentally picked up the AS paper, because this is so AS-y, isn't it? So if we go for A equals calls in 30 minutes, because that's what we're asking for part A, and then A is a Poisson with a mean of, well, you've got 1.25 in 10 minutes, so we've got 3.75 in 30 minutes. And we want the probability that X is at least 2, so not X, is greater than or equal to 2. So probability that A is greater than or equal to 2. Let's grab the calculator. Let's go to our distributions menu, our Poisson distribution. We want greater than or equal to 2 with a mean of 3.75. And we will see that is 0.8882. We'll always look at it. 88829, and we were asked to round that, so 0.888 to 3 significant figures. 3 decimal places, 3 significant figures, yeah. Part B, calculate the probability that at least two calls are arranged in fewer than 4 out of... Okay, so this is linking into a binomial, isn't it? So let's say B equals the periods with at least 2 calls. And we've just done the probability of that. That was that one there, isn't it? So B is a binomial. We've got 6 periods we're looking at, and the probability of getting more calls than that is 0.88829. We want the probability that fewer than 4 is less than or equal to 3. And so let's go for this. Right, let's menu 1. Let me just get something up for you. Look, if I do variables, statistics, result of the distribution P, and look, that's that number we just had there a second ago. And if you now just put that into A, I've stored it there. Now, when I go into my distributions mode and I'm going into binomial, what do I want? I want less than or equal to 3 from 6 trials. And what was the probability? Well, I haven't got to type it all in again. I had it in A already, so I can just stick it straight in there. And so the answer here, we've got 0.0214, and rounding that, let's have a look at that exactly, 214795. And so to 3 significant figures, we get 215. So it's one of those ones where you've got to be careful. If I only wrote 214, I might not get that right. And so there's that bit there. So C, a manager selects 150 overlapping 30-minute periods. She records the number of calls in each of these, and we want to know the number of 30-minute calls when exactly 8. Okay, so first of all, I need to know the chance of getting exactly 8 in 30 minutes. So that's where we were before. So let's just go back to our Poisson distribution. Hopefully it's all still there, is it? Yep. And we want this time exactly 8. The chance of getting exactly 8 is 0.0228. Let's look at it a bit more. 2281. Oh, look at that. 000. They picked a nice one there, didn't they? But we are trying to do, so A, B, C. C is a binomial, and we've got 150, and the probability of it happening 0.02281. I've not defined what C is, have I? I should have said C equals the periods with exactly 8, sorry, the periods with exactly 8, blah, blah, blah. Now look, this binomial here, we don't actually want to do it, although we could. We want to use it as an approximation. So rather than doing the binomial, we're going to change this to a Poisson, And to find out what the mean of the Poisson is, we times those two things together. So back to my Poisson, my new mean is 150 times by 0.02281. Can't be bothered to use the P version of that this time. So that is 3.4215. And we want at least 3 of them. At least 3. At least 3. Greater than or equal to 3. So the probability that C is greater than or equal to 3 is equal to, and I've got it there, 0.6643, and that's what they were hoping us we had, didn't it? 664 to 3 significant figures. It's actually 664389 if you wanted a few more there. Should we just do one more bit of this because it's gone on quite a bit? So part D, explain why the Poisson approximation may be reasonable in this case. Well, we could go with n large and p small. That's one way of writing that. We could go, or we could actually sort of figure out what sort of the mean. The mean here was equal to, we had it there, 3.4215. And the variance, well, the variance is equal to 3.4215 times by 1 minus that, which again is going to be very similar. And these are very the same. These are similar. One of the properties of the Poisson was that the mean and the variance would be the same. But really it comes from this, that the n value is large and the p value is very small.